Hi everyone, welcome back to our channel. Today we are going to solve problem number 38. This is on maximum power transfer theorem. Find the value of RL such that maximum power will transfer. Okay, if you want to find out, first we need to find out open circuit voltage, which is VOC, and second we need to find out R Thevenin, and the formula for the maximum power to transfer is P maximum is equal to VOC whole square divided by 4 R Thevenin is our formula. So we need to find out this. Okay. So in order to find out this, let us first find out the value of VOC. Okay, so the procedure of finding VOC is remove the load resistor, okay, and calculate the open circuit voltage. I am redrawing the network. This is 5 amperes, this is 2 ohms, and here we are going to get positive VOC, and here you are going to get the negative VOC, continued with 10 as well as 24 volts. Okay, so this is VOC. So now I am skipping this VOC and I am writing this VOC here. Okay, so the VOC is removed, and here we go. We have, I'm writing this as node A and this as node B, and the voltage between this is nothing but VOC. Therefore VOC is equal to the difference of node A and the difference of voltage at node B. Okay, so therefore we need to find out. So now I require the value of VA as well as VB. Okay. So let us try to see here how to find out. So in order to understand that, already in this branch and 5 amperes current is entering, and in this branch current is leaving. Let's try to mark this current as some I1. Okay. To find the value of VB, apply nodal analysis or apply Kirchhoff's current law at node VA. Okay, so in this branch, how many entering currents are there? So we can see 1 ampere, 5 ampere current is entering, and what is the leaving current, which is nothing but I1. Okay, so 5 is equal to, how to write down this I1 current which is flowing in this direction? I can write down it as VA minus 0 divided by 2. Therefore, VA value is equal to 5 into 2, which is nothing but 10 volts. So, we successfully find the value of VA. Let's try to find out the value of VB. Okay. So, in order to perform it, apply nodal analysis, which is nothing but Kirchhoff's current law at node VB. Okay, so I1 is completed. Let's try to mark this current as some I2 and mark this current as some I3. Okay, so this is the direction of I2 and this is the direction of I3. Okay, so you can see here both the currents are leaving. So when you apply the KCL, entering currents are 0, the leaving currents are I2 plus I3. So 0 is equal to, how to write down I2? I want to write down this current I2 which is flowing in this direction. So what is the higher potential? Plus VB minus 0 divided by R. R value is how much? 5, plus how to write down the current which is flowing in this branch. So VB, so it is leaving, or the leaving polarity of the voltage VB. Okay, and current is traveling like this. What is the polarity here? Minus VB minus 24 divided by 10. Okay, so then we are going to get this value. So 0 is equal to VB by 5 plus VB by 10. So when it comes to this is nothing but minus 2.4. This is 2.4 is equal to VB, if you take common, 1 by 5 plus 1 by 10. So use your calculator then we are going to get the value of VB is equal to 8 volts. But actually what I require is VOC, VA. VA is how much? 10. VB is how much? 8. Okay. So 10 minus 8, we are going to get the VOC is equal to 2 volts. Okay. That is equal to 2 square divided by 4 into RThevenin. Now we need to find out the value of RThevenin. Okay. How to find out RThevenin? If any, this is the current source of how much? 5 ampere. We need to deactivate this one. So this 5 ampere source has to be deactivated, means we need to perform it like an open circuit. Automatically current will become 0. And we are having a 24 volts source. Okay, so this source has to be made short circuited. I mean, this 24 volts has to be deactivated. Deactivating means making the voltage as 0, therefore V is equal to 0. Okay, now perform the same here. So now this source is open circuited, and we are having a 2 ohm resistor, and this is the load resistor, and this is 5 ohm, and this is 10 ohm, and this source is short circuited. Okay, why? Because this is a voltage source, this is short circuited, this is open. And now we are looking from these two terminals and we are finding the value of RThevenin. Okay, here you can see here the current starts entering and current is dividing. Whenever the current is divided, I can say these two are connected in parallel. Okay. So if you have any doubt, mark this node as sum 1 and mark this node as 0. Okay. So now between 1 and 0, how many elements are connected? Two elements are connected. Therefore, we are going to get a single resistor between node 1 and 0. So 1 and 0, 5 is connected, and 1 and 0, 10 is connected. So when two resistors are connected in parallel, the formula is product of resistance divided by sum of resistance. And here we are going to have, so current will flow like this, and current will not flow in this branch. The same current will be flowing. Okay. So here we are going to have the 2 ohm resistor. This is 2 ohm resistor, and when you find out this value, you're going to get as 3.33 ohms. And from this point we need to find out R Thevenin. Okay, so the current flows like this. Okay, and I can say now the current is constant. These two are now connected in series. Okay, so this is 2 plus 3.33, which is nothing but 5.33 ohms. Okay, so this is the value of R Thevenin. So that is equal to, now the RThevenin value is how much? 5.33. So 4 into 5.33, that is equal to, and use your calculator, 2 square into 4 into 5.33, you are going to get it as 0.1876 watts. So this is the maximum power consumed by the load. Okay, so hope you are able to understand. I need to find out open circuit, so I have performed the open circuit. Directly I can't find out open circuit. I am marking this node as some VA node and another node as VB node. VA and VB node. I applied the nodal analysis at each node and I obtained the values of VA and VB. I subtracted VA minus VB, had got the value of VOC. And similarly here I open circuited this current source and I short circuited this voltage source, and looking from the open circuited terminal I find the value of RThevenin. I directly substituted in this, and this is our formula. If you feel my content is useful to you, please like the video. Please share your friends, those who are studying this subject. And if you have any doubts and any confusion at any point, let me know in the comment section. I can answer your comment in my free time. And if you're watching the channel for the first time, subscribe to my channel with the name KV Theorem, and kindly support this type of free channel for the benefit of students as well as for the faculty. So thank you for watching the channel patiently. Thank you for understanding. So if you directly see this video, just to get an awareness how to solve the problem. But what is the procedure of studying is write down the given question as it is, and what are the procedure I implement, the same procedure you also implement, then you'll get the same answer. Then automatically the confidence will develop in your brain. Automatically you can solve more problems. So thank you for watching. We'll meet in the next video.